Okay, so basically for the car, we're going to need a gear selector. And originally I was going to do a touchscreen one, but then I realized there's a few problems with that. The pros and cons of a touchscreen gear selector is first, if the screen is a capacitive touchscreen, then I actually have to use a finger or a stylus to choose the gear, which means that if I have gloves on, it may not work if I have like leather gloves or gloves that aren't capacitive touch, like you know the fingerprint one, whatever. Yeah, if I don't have those, it won't work. Second is if I use a phone or a tablet as my display, there's been problems that I've seen with people who've done like the Brainiac displays where they set the cars in the sun, then they have to wait for the car to cool down to use or to switch or to just use tablet because it's overheated. Well, I'm not using any of Brainiac's stuff, so that's not really a problem. But the problem is if I use any type of other tablet, even my own, if it's still in direct sunlight, it could be a problem. I don't see a problem like, oh, I go, my car is hot. Okay, turn the car, let it cool down. That's not a problem. The problem is, let's say I park my car somewhere. I need to rush in and go do something, come out, and I need to move my car immediately. I can't sit there and wait for it. So that's one thing. That's one thing to keep in mind. So what I decided to do was go with this right here, and also space. I gotta figure out how I'm gonna do space. So to save on all that, I decided that for right now, instead of just doing like little flip switches and everything that I've seen a lot of people do, I'm going to actually use one of these rotary encoders. My friend, he recommended using a Hall effect sensor. I'll look into that in the future, but these are easier and cheaper. These are like, what, $1, maybe even less. Really, if you order from China, they come in at probably even like 30 or 40 cents, but they're cheap, easy to replace and things like that. So you can already see I kind of 3D printed like that dark gray piece right there. And the dark gray piece is only for me to test to make sure the hole is big enough for the 3D print. Next, what we're gonna do is we're actually gonna print like a knob. One of the knobs that I got an idea from was from the Lexus. Okay, so when I first tried to print this, I print this ring. I had to go through like 3 or 4 prints only because first I tried to do almost an exact size with a few like a fraction of a millimeter wider, and it didn't work. So what I ended up doing was I ended up printing a little bit wider and then tapering out the design in the center, because if I didn't taper the design, it was, I think the top part of this is a close fit where it just wouldn't, like, it's just not working. And I know when I do the bigger print, like I got that to work by forcing it, but if I do a bigger print, for example, with this, then with the bigger print, it's not going to have that much flex, at least like this does, to like force it on. So what I did was I did a tapper type of design. You know, y'all can see that on the edge right here. If not, I'll just show a screenshot of it. And basically it makes it easier just to go like this, and it's up there. And I still need enough tension from the ring or like the hole in the center so I can be able to rotate this. And as you can see, it rotates perfectly. So that works. And what I'm planning to do is when I put the knob on, it's going to take, right now on my computer, it's saying it's going to take 35 minutes. So we're going to print that out. So I don't know if you noticed this, but I kind of try to get this to go on a breadboard so I could prototype, but that didn't work. And these little pins right here are really flimsy. So one thing I am worried about in the car is how easy these will break from the vibration. So I don't know if I need to do like a stress load or something on it or whatever. But what I'm gonna do for right now is I strip some wires over here. And what I'm gonna do is I am going to solder those to here. That way I can test with a breadboard, and we're gonna write the code for choosing the gears, and yeah, that just be it. Right. So if we do clockwise, numbers increasing. Counterclockwise, numbers are decreasing. Okay, so basically now that y'all see that that works, what I'm gonna do is I'm gonna go ahead and merge, or not merge my code in. I'm thinking about GitHub and stuff. But what I'm gonna go do is I am going to take these indexes, parse them out into like a JSON or something, and then I'm going to use that, and basically when I pass that on to the main like display for this gear selector, then I am going to write code that looks at the numbers of the index, and it's going to, if the index is greater than the previous one, it's going to go right for yeah, if I say that right, yeah, it's going to go, if it's counterclockwise, the index is increasing. As the index increase, we will go to the right to select the gear shift, and as the index decrease, we're going to go to the left to select the yeah, we're going to go to the left to select the can't think of the name right now. We are going to go to the left to select the other direction. It's been a long day. Okay, so this is like something similar to what I did on Fusion 360s. Like I made this, but I hollowed out the center only because it made the print easier. I think I have a photo of it, and if I do, I'll add it to the video. So this is a new one. So the way it's going to work is we're going to make this hole right here in the center. That hole right there is what we're going to press onto the rotary encoder, and then when it's in the 350, from when you're sitting down a driver's view, you're actually going to see it at like this view, and then you just turn it, to switch to the gears, even though we don't have gears. So let's say the drive mode. Cool. So that's my item I'm going to print. We got 35 minutes, and it's going to use basically 4 grams of PLA. So yeah, so we're gonna... All right, so the print is done, and I don't know if you can see that, but like you see the squares inside, that's because I didn't make the top layer that thick, but the top part is actually super smooth. Like it's smooth, like it actually feels like, almost like it was like plexiglass, like a flat sheet of plexiglass. Like look at the light shine on it. There's like no ridges in there at all. It's like, all right, so we're done printing for the night. So as you can tell, the color of this is actually turning gray now. The reason why it's turning gray is because this is a heat sensitive filament. So basically as it gets colder, which is like room temperature, it's gonna turn gray. And when it gets hotter, like around, I think it's like 85 degrees or hotter, it turns white. But when we print this out again, it's gonna be all black. So take this, press to the bottom like that, and then just gotta basically put it in until we get there, and there we go. While I'm talking, you may even see the time update down here to show the display works. At least, that time is working constantly. Also, this is, the print that I just talked about earlier. I'm thinking about implementing the push button for selecting the gear, because right now the way I have it set up is I'm just gonna basically rotate it, and when it rotates it's just gonna select the gear or the drive mode. All right, so basically I'm thinking about implementing a 3 fail-safe type of drive mode or drive mode selection system. So the first one would be like, hey, my foot is on the clutch pedal or the brake pedal. I'll figure out which one I want to put the sensor on. The second would be probably adding the push button. So that's me actually selecting, the gears. So that way if I'm braking, let's say if I hook up the first fail-safe to the brakes, and then I'm braking in the car, let's say like traffic is approaching, I'm braking or stop sign, and my arm hits the gear selector. I don't want to switch gears and think I want to throw it in reverse while I'm still moving forward. So I'm thinking about implementing the push button. Next is I'm also thinking about, or not thinking about, this definitely be there. It's going to be like a software check, and the software check is what it's going to do is it's going to be what's reading the RPM on the motor, and I don't know if I want to read in like the voltage and the amps going to the motor. I think just the RPM alone from my RPM sensor should be good enough. And if I'm over a certain amount of RPMs, like when I say over a certain amount, it's really basically if the motor is moving, I don't want the reverse contactor switching. So I'm still going to check them, also make sure there's no load applied. So the brake being enabled should kill power going to the motor. However, at the exact same time, even if power is killed to the motor, if I'm going like 30, 40 miles forward, I don't want to be throwing this thing in reverse and then this thing acting like almost like trying to do regen on my controller, because that is going to be a problem. In the part 2 of the next video, what I'm going to do is I am actually going to basically show a bigger print of the actual like gear selector knob. I'm probably going to extend these wires out and actually do like a full print for how this fits in the Z in the little ashtray. That's where I'm actually going to put this at. This is going to be an ashtray. And when it's in the ashtray, When I'm thinking about some sort of bracket that's kind of like a bolt-in system. So I don't know if anyone else does this build or whatever. And I'm also thinking about publishing the 3D print for the knob line and the link to the sensors. So yeah. So if y'all like this video, please like and subscribe. And yeah, that's it.